After learning Heisenberg's uncertainty principle, we came to know that it is impossible to determine the exact position and momentum of moving particle like electron. So then this rule is not considering that Bohr's model. So it will not accept that Bohr's model, isn't it? Now we can guess. So here it is not possible to determine the exact position and momentum of electron, but we can say probability. Instead of telling exact, we can use the term probability. Probability of finding electron in specific place in an atom. For explaining regarding that position and momentum of electron, we need dual nature of electron. That means electron will be having both particle property as well as wave property. So in order to explain that probability of finding electron, one more theory we have to learn, that is nothing but quantum mechanical model of atom. That means we can't accept Bohr's model as 100% right model for an atom. Then we need to go in depth. So how these electrons will be revolving around the electron. So what are the directions, three-dimensional arrangement of these electrons? Where do we find these electrons exactly, even in the orbit? Now, once you consider this quantum mechanical model, so this is one of the branch of science. It is mainly dealing with that dual behavior of the matter. So actually classical mechanics anta consider madadaga, for example Newton's law of motion anta consider madadaga, we can say that ಈಗ ಒಂದು ಕಲ್ಲನ್ನ ಮೇಲಕ್ಕೆ ಎಸೆದಾಗ ಮತ್ತೆ ವಾಪಸ್ ಏನಾಗುತ್ತೆ, ಕೆಳಗೆ ಫಾಲ್ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಡ್ಯೂ ಟು ದ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್. ಈವನ್ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ that there will be different planets which will be revolving around our sun, that is in the solar system. So we can consider there are many classical mechanics, that means classical theories. Here if you say that those are the larger objects, there they can consider they are said to be particles. They will not consider the wave property with respect to those macroscopic matter. But if you come for microscopic matter, that is in case of atoms, subatomic particles, those are very minute in size. They are said to be microscopic objects. These matters where they are said to be microscopic objects, we can't consider them only with respect to particle property, isn't it? So ಹಾಗಾದ್ರೆ microscopic particles ಏನಿದೆ, ಪ್ರೋಟಾನ್ಸ್ ಇರಲಿ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರಲಿ, ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರಲಿ, ಅದಕ್ಕೆ ಪಾರ್ಟಿಕಲ್ ಪ್ರಾಪರ್ಟಿನೂ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗತ್ತೆ, ವೇವ್ ಪ್ರಾಪರ್ಟಿನೂ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ನಾವು ವಿ ಕ್ಯಾನ್ ಗೆಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಮೂವ್ಮೆಂಟ್. ಸೊ ಇಟ್ ಈಸ್ that matter which has got certain movement. So that means it will be having certain velocity also. So we need to find its position and velocity, that is along with that mass that is considered as momentum. Now here according to this, that is the branch of science that takes into account that dual behavior, that is specifically particle and wave property of which one, matter, that is especially that matter with respect to subatomic particles, very microscopic in nature. It is called as quantum mechanics. That means quantum mechanics is mainly dealing with the study of the dual nature of the microscopic particles. We can consider atom as well as molecules. And here this quantum mechanics, it was mainly developed by the two scientists. So one is Heisenberg, other one is Schrodinger. They developed this theory, and this is one of that theory which is much helpful for predicting the probability of finding electrons in an atom. So it is mainly based on the wave motion. That means they are considering the wave property of the electrons, that is atoms. As a total we can consider atom as a system. We are considering atom. That means we can take either atom or a molecule. Here it is considered with respect to one system. That means use it to determine the total energy of the system. ಈಗ ಯಾವ್ದಾದ್ರು ಒಂದು ಆಟಮ್ಗೆ ಟೋಟಲ್ ಎನರ್ಜಿ ಏನಿದೆ ಅಂದರೆ ಆಟಮ್ದ ಎನರ್ಜಿ ವೇರಿಯೇಷನ್ ಇರಲ್ಲ. ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಟಮ್, ಐಸೋಲೇಟೆಡ್ ಆಟಮ್ ಅಂತ ತಗೊಳ್ಳಿ. ಸೊ ಆಟಮ್ಗೆ ಟೋಟಲ್ ಎನರ್ಜಿ ಎಷ್ಟಿದೆ, ಸೊ ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಲಿಕ್ಕೆ ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ expression, or that equation is called as Schrodinger equation. This is one of the most important expression, that is Schrodinger equation, which is much helpful to determine that total energy associated with any particular system. So ಈಗ expression ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, that is it is H symbolized as H, but we should not call it as H. It is Hamiltonian. It is one of the mathematical operator. So it is actually very complicated expression. As you can see, we can read it very easily like H psi is equal to E psi. It is not H. It is one of the complex mathematical operation. It needs several steps. But you are going to learn those solutions for this with the help of this expression in the higher studies. That is, when you go for higher classes, then you are going to learn about that Schrodinger wave equations, how to solve that in detail. But I will brief out with respect to this concept. If you know this expression, it is more than sufficient. It is Hamiltonian psi is equal to E psi. This is E is with respect to the energy of that system, whether it is atom or a molecule. Now, once you consider that total energy of the system, that takes into account the kinetic energy of all subatomic particles. ಅಂದರೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಸಿಂಗಲ್ ಆಟಮ್ ಅಂತ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆಟಮ್ದು ಟೋಟಲ್ ಎನರ್ಜಿ ಯಾವುದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ, ಆ ಆಟಮಲ್ಲಿ ಏನೆಲ್ಲ ಸಬ್ ಅಟಾಮಿಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರುತ್ತೆ, ಆ ಸಬ್ ಅಟಾಮಿಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಎನರ್ಜಿನೆಲ್ಲ ಸಮ್ ಅಪ್ ಮಾಡಿದಾಗ ಟೋಟಲ್ ಎನರ್ಜಿ ಏನು ಸಿಗುತ್ತೆ, that will be found out with the help of this expression. That means the total energy of the system takes into account the kinetic energy of all subatomic particles. ಈಗ ಆಟಮ್ ಅಂತ ತಗೊಂಡಿದ ತಕ್ಷಣ ಆಟಮಲ್ಲಿ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ, ಪ್ರೋಟಾನ್ಸ್ ಇರುತ್ತೆ. ದೇ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ಸೈಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್. ಅದೇ ಥರ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮಧ್ಯದಲ್ಲಿ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸಸ್ ಇರ್ಬೋದು. ಅದೇ ಥರ ನ್ಯೂಕ್ಲಿಯಸ್ ಮತ್ತು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮಧ್ಯೆ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸಸ್ ಇರ್ಬೋದು. That means each and every individual subatomic particles will be having their own kinetic energy, isn't it? Hagadre, some of those kinetic energies of all those individual particles, including the repulsive forces as well as the attractive forces, finally you are going to get that value, that is with respect to total energy of the system. Then, now if you guess, that is, what is the psi? Psi stands for wave function. It is actually representing an orbital. Now, here the solution of this equation gives, by solving this complex expression, that is Schrodinger equation, then you are going to finally get the values of E, energy, and psi. What is the psi stands for? Psi actually it is representing an atomic orbital wave function. That means psi stands for PSI. So we can pronounce it as psi. Psi stands for, it is a wave function of the atomic orbital. ಅಂದರೆ ಆಟಮಲ್ಲಿ ನಿಮಗೆ ಇದುವರೆಗೂ ಕೆ ಶೆಲ್, ಎಲ್ ಶೆಲ್, ಎಮ್ ಶೆಲ್ ಅಂತ ಕರಿತೀವಿ, ಅದನ್ನೆಲ್ಲ ಆರ್ಬಿಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಆ ಡಿಫ್ರೆಂಟ್ ಶೆಲ್ಸಲ್ಲಿ ಅಗೇನ್ ಯು ವಿಲ್ ಕಮ್ ಅಕ್ರಾಸ್ ದ ಆರ್ಬಿಟಲ್ಸ್. ವೇ ಡು ಯು ಫೈಂಡ್ ದ ಆರ್ಬಿಟಲ್ಸ್? ಆರ್ಬಿಟಲ್ಸ್ ಆರ್ ಫೌಂಡ್ ಇನ್ಸೈಡ್ ಆನ್ ಆರ್ಬಿಟ್. ಲೈಕ್ you have heard about s orbital, p orbital, d orbital, f orbital. They are present in different shells. Now, once you consider that solution of this equation gives the energy values as well as the psi value, then in hydrogen atom, if you take example, even by considering this hydrogen atom, it is helping to, or it gives possible energy levels of the electron can occupy and corresponding wave function. ಅಂದರೆ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನು ಯಾವ ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಲೆವೆಲ್ ಅಲ್ಲಿ ಅಥವಾ ಆರ್ಬಿಟ್ ಶೆಲ್ ಎನರ್ಜಿ ಲೆವೆಲ್ಸ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಆಕ್ಯುಪೈ ಮಾಡ್ಬೋದು, ಮತ್ತೆ ಯಾವ ಪರ್ಟಿಕ್ಯುಲರ್ ಶೆಲ್ ಅಲ್ಲಿ ಯಾವ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಳ್ಬೋದು, ಆ ಪ್ರಾಬಬಿಲಿಟಿನ ಈ ವೇವ್ ಫಂಕ್ಷನ್ ಇಂದ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. In hydrogen atom, it gives possible energy levels the electron can occupy. Energy shells ಏನಿದೆ ಎಲ್ಲಿ ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಳತ್ತೆ ಅದ್ರ ಬಗ್ಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಡುತ್ತೆ. ಅಂಡ್ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ವೇವ್ ಫಂಕ್ಷನ್ಸ್ ಅಂದರೆ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಆರ್ಬಿಟ್ ತಗೊಂಡಾಗ ಆರ್ಬಿಟಲ್ ಯಾವ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಅದು ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಳತ್ತೆ, that information is given with the help of this expression. Then similarly, not only hydrogen, so even we can go for other atoms also. Now we can say that many such wave functions possible for electron. ಹಾಗಾದ್ರೆ ನಾವಿಲ್ಲಿ psi ಅಂತ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಆ ವೇವ್ ಫಂಕ್ಷನ್ನು ಒಂದು ಸ್ಪೆಸಿಫಿಕ್ ಎಲೆಕ್ಟ್ರಾನ್ನ ತಗೊಳ್ಳಿ. ಆ ಎಲೆಕ್ಟ್ರಾನು ಎಸ್ ಆರ್ಬಿಟಲ್ ಇದ್ದಾಗ ಒಂದು psi ಫಂಕ್ಷನ್ ಅಂತ ಏನು ಬರುತ್ತೆ, ಅದೇ ಥರ ಅದೇ ಎಲೆಕ್ಟ್ರಾನು ಪಿ ಆರ್ಬಿಟಲ್ ಇದ್ದಾಗ ಬೇರೆ psi ಫಂಕ್ಷನ್ ಬರುತ್ತೆ. ಹಾಗಾದರೆ ಒಂದೇ ಎಲೆಕ್ಟ್ರಾನ್ಗೆ ಬೇರೆ ಬೇರೆ psi ಫಂಕ್ಷನ್ಸ್ ಬರೋ ಪಾಸಿಬಿಲಿಟಿ ಇದೆ ಅಂದರೆ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಆರ್ಬಿಟಲ್ ಇನ್ ವಿಚ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್. ಮೆನಿ ಸಚ್ ವೇವ್ ಫಂಕ್ಷನ್ಸ್ ಪಾಸಿಬಲ್ ಫಾರ್ ಎಲೆಕ್ಟ್ರಾನ್ and therefore there are many atomic orbitals in an atom. ಹಾಗಾದರೆ ಒಂದು ಆಟಮಲ್ಲಿ ಒಂದೇ ಒಂದು ಆರ್ಬಿಟಲ್ ಅಲ್ಲ, ಒಂದೇ ಒಂದು ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್ ಇರಲ್ಲ. there is possibility for many atomic orbitals in an atom. So all that informations about an electron is stored in psi. That means what are the psi values we are going to get while solving this expression? Depending on that psi, we are going to get the information regarding the electron. ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ ಆರ್ಬಿಟಲ್ ಇದೆ ಮತ್ತು ಆ ಆರ್ಬಿಟಲ್ ಯಾವ ಆರ್ಬಿಟಲ್ ಇದೆ, ಅದಾದಮೇಲೆ ಯಾವ ಆರ್ಬಿಟಲಲ್ಲಿದೆ ಅಂತ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಬೋದು. ಸೊ ದಟ್ ಈಸ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದಿ Schrodinger equation. Finally, we can consider that probability of finding an electron at a point within an atom, that is given as psi square. Psi ಅಂದರೆ ವೇವ್ ಫಂಕ್ಷನ್ ಆಫ್ ಎನ್ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್. ಅದೇ psi ಸ್ಕ್ವೇರ್ ಅಂದರೆ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಫೈಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿತ್ ಇನ್ ಆನ್ ಆಟಮ್. ಅಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಯಾವ ಆರ್ಬಿಟಲ್ ನಿಮಗೆ ಜಾಸ್ತಿ ಸಿಗುತ್ತೆ, ದಟ್ ಗಿವ್ಸ್ ದಟ್ ಆಲ್ಮೋಸ್ಟ್ ದ ಮೋಸ್ಟ್ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಫೈಂಡಿಂಗ್. ಇಲ್ಲಿ ಎಕ್ಸಾಕ್ಟಾಗಿ ಅಲ್ಲೇ ಇದೆ ಅಂತ ಹೇಳ್ತಿಲ್ಲ, ಬಟ್ ಮೋಸ್ಟ್ ಪ್ರಾಬಬಲಿ more than 90% ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, ಮೋಸ್ಟ್ ಪ್ರಾಬಬಲಿ, ಲೈಕ್ probability of electron will be more in that specific orbital. So hence it is given by that term psi, and including that psi, it is written in terms of psi square. So there is a difference in psi and psi square. Psi stands for wave function of atomic orbital or atomic orbital wave function, whereas psi square stands for probability of finding electron, that is at a point within an atom. Got it? So this quantum mechanics is helping us to find the information regarding an electron. We can easily find out that nature of that electron and all the information, energy, like regarding electron energy, how much energy is associated with that electron, in what three-dimensional way it is just present around the nucleus in an atom. All this information will be obtained with the help of this Schrodinger wave equation. It is also considered Schrodinger's wave equation or Schrodinger equation. So far we have learnt many concepts regarding an atom and the subatomic particles. So we have learnt atomic models, then even we have learnt Planck's quantum theory, de Broglie's wavelength equation, Heisenberg's uncertainty principle, Bohr's atomic model. After learning all these, we came to know that atom will be having specific model. So most of the postulates of Bohr's, which is much helpful to explain an atom. And of course, if you come for electron will be present, that is revolving around the nucleus, but it will be present in specific orbit, what we can say, but it is very difficult to find in which particular position it is exactly present in an orbit. That is, of course, we can say orbit is two-dimensional, we can guess in which orbit it is present, but not exactly the three-dimensional space or the region in that orbit around the nucleus where you can find that electron. Therefore, we can say the probability of electron. Not exactly, we can say only use the word probability. So now we can say these electrons which have got certain properties, that energy, specific energy of electron, its properties mainly depends on the quantum numbers. Quantum mechanics, that is Schrodinger equation, is also helpful to explain the complete characteristic of electron present in any particular atom. That means each and every electron will have got own energy and its properties. It's mainly based on the orbit, type of the orbit and type of the orbitals. Then you should know what is meant by orbital. We have not come across yet what is meant by orbital. Of course, you know that orbit, that is orbit means you know that it is a shell or energy level, we can say. Now, we are going to learn about these two terms and we are going to have certain differences between these two. Orbit andre ಏನು, ಆರ್ಬಿಟಲ್ ಅಂದರೆ ಏನು. ಈಗ ಫಸ್ಟ್ ಒಂದು ಆಟಮಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ಏನು ನ್ಯೂಕ್ಲಿಯಸ್ ಇರುತ್ತೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ಡಿಫ್ರೆಂಟ್ ಆರ್ಬಿಟ್ಸ್ ಇರುತ್ತೆ. ಹಾಗಾದರೆ ಆರ್ಬಿಟ್ ಅಂದರೆ ಏನಲ್ಲಿ? ಆರ್ಬಿಟ್, ಇಟ್ ಈಸ್ ದ ಫಿಕ್ಸ್ಡ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಟೂ ಡೈಮೆನ್ಷನಲ್. ಅಂದರೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ಏನು ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ಸ್ ಇರುತ್ತೆ, ಡೆಫಿನೆಟ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ಸ್ ಇರುತ್ತೆ, ದೇ ಆರ್ ಸೆಟ್ ಟು ಬಿ ಟೂ ಡೈಮೆನ್ಷನಲ್. ದಟ್ ಡೆಫಿನೆಟ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ವೇರ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಬಿ ರಿವಾಲ್ವಿಂಗ್, ದಟ್ ವಿಲ್ ಬಿ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಆರ್ಬಿಟ್. ಅಂದರೆ ಇಲ್ಲಿ ಫಿಕ್ಸ್ಡ್ ಅಂತ ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ದರ್ ವಿಲ್ ಬಿ ಡೆಫಿನೆಟ್ ರೇಡಿಯಸ್ ಫಾರ್ ಎನಿ ಆರ್ಬಿಟ್, isn't it? That means there will be a gradual increase in the distance from one orbit to the another orbit as you move away from the nucleus. ನ್ಯೂಕ್ಲಿಯಸ್ ಇಂದ ದೂರ ಹೋಗ್ತಾ 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 ಆರ್ಬಿಟ್ಸ್ಗೆ, ಹೈಯರ್ ಆರ್ಬಿಟ್ಸ್ಗೆ ರೇಡಿಯೈ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಏನಾಗುತ್ತೆ, ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ, ಎನರ್ಜಿ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ನೌ ಒನ್ಸ್ ಯು ಗೋ ಫಾರ್ ಆರ್ಬಿಟಲ್, ವಾಟ್ ಈಸ್ ಮೆಂಟ್ ಬೈ ಆರ್ಬಿಟಲ್? ಈಗ ಒಂದು ಆಟಮ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ, ಆಟಮಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಸುತ್ತ ಏನು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇವಾಲ್ವ್ ಆಗ್ತಿದೆ ಅಂತ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ, ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆರ್ಬಿಟಲ್ಲಿ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದೆ. ಬಟ್ ಆರ್ಬಿಟಲ್ಲಿ ಎಲ್ಲಿ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದೆ, ಯಾವ ಆರ್ಬಿಟಲಲ್ಲಿ ಇದೆ, ಸೊ ಯಾವ 3 ಡೈಮೆನ್ಷನಲ್ ರೀಜನಲ್ಲಿದೆ, ಆ 3 ಡೈಮೆನ್ಷನಲ್ ರೀಜನಲ್ಲಿ ಎಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ದು ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಫೈಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ in that specific 3-dimensional region around the nucleus, that will be specifically called as orbital. Agar orbital andre eno, it is the 3-dimensional region in space where, that is around the nucleus of an atom, in which the probability of finding electron is more with specific energy. Agar illi matte ನಾವು 3-dimensional region ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. ಒಂದು ಆರ್ಬಿಟಲ್ ಅಂದರೆ ನ್ಯೂಕ್ಲಿಯಸ್, ಸರೌಂಡಿಂಗ್ ನ್ಯೂಕ್ಲಿಯಸ್. ಆರ್ಬಿಟಲ್ ಒಂದು 3-dimensional ಸ್ಪೇಸ್ ಅಂತ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಅಲ್ಲಿ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ಹೈಸನ್ಬರ್ಗ್ ಅನ್ಸರ್ಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಕಲ್ತಿದ್ದೀರ, ಅದು ಕಲ್ತ ಮೇಲೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅಂತ ವಿ ಕಾಂಟ್ ಸೇ. ಸೊ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಫೈಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಬಿ ಮೋರ್. ಒನ್ಸ್ ಅಗೇನ್ ಐ ವಿಲ್ ರಿಪೀಟ್, ವಾಟ್ ಈಸ್ ಮೆಂಟ್ ಬೈ ಆರ್ಬಿಟಲ್? ಇಟ್ ಈಸ್ ದ 3-dimensional, ಇಟ್ ಈಸ್ ನಾಟ್ 2-dimensional, ಇಟ್ ಈಸ್ 3-dimensional. ಅಂದರೆ we can consider 3 axes, x-axis, y-axis and z-axis. One will be x, another will be y, another will be z. Like x-axis, y-axis, 3-dimensional region if we consider. So it is 3-dimensional region in space around the nucleus of an atom, in which the probability of finding electron is more. And even it has got with specific energy. ಅಂದರೆ ಯಾವ ಆರ್ಬಿಟಲ್ ಇದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ, ಯಾವ ಆರ್ಬಿಟಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಅದರ ಡೆಫಿನೆಟ್ ಎನರ್ಜಿ ಕೂಡ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. ಇಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಇಟ್ಸ್ ಓನ್ ಸ್ಪೆಸಿಫಿಕ್ ಎನರ್ಜಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಆರ್ಬಿಟ್ ಅಂಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಆರ್ಬಿಟಲ್. ದೆನ್ ಆಫ್ಟರ್ ನೋವಿಂಗ್ ದ ಡೆಫಿನೇಷನ್ ಫಾರ್ ಆರ್ಬಿಟ್ ಅಂಡ್ ಆರ್ಬಿಟಲ್, ಇನ್ ಕೇಸ್ ಇಫ್ ದೇ ಆಸ್ಕ್ ಫಾರ್ what are the differences between orbit and orbital, you can easily list out these different differences. You can distinguish both of them with these points, which is that very first point regarding difference of orbit and orbital. Orbit, it is a definite circular path around the nucleus in which electron revolves. It is a definite circular path in which we can find that is present around the nucleus in which electron revolves. But what about orbital? It is the 3-dimensional region around the nucleus in which there is probability of finding electron. Probability of finding, I am repeating, probability of finding electron is maximum. For the first difference, you can write the definition itself. Then what is the second definition you can remember? Its shape is circular. Of course, we can easily guess it will be circular in shape. Around the nucleus, there will be circular paths, different circular paths. Then its shape is circular. Then here it can be spherical or dumbbell shape or double dumbbell shape. Spherical means round shape. Dumbbell shape, 2 lobes will be present, the pair of lobe, and 2 pairs, one pair that is above and below. It is having the shape of dumbbell, and double dumbbell means two pairs of lobes here. So double dumbbell shape. Then we can go for next difference. It can accommodate a maximum of, it can accommodate means it can occupy maximum of how many electrons? 2n square electrons. If you specifically go for first shell, for example, you can write 2 into n value, first energy level 1, n square, 1 square. Therefore, 1 square is 1 itself. 1 into 2 is 2. Only 2 electrons will be found in first energy. Like if you go for next second energy level, 2 into 2 square, that is 2 2s are 4, 4 2s are 8. In the second energy shell or the second shell, you will find how many electrons? 2 into 4 is, that is 8 electrons. So with the help of this expression, you can easily remember, we can easily find out the maximum number of electrons can be accommodated in specific orbit. Our n value ಯಾವ ಶೆಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವೋ, ಯಾವ ಶೆಲ್ ನಂಬರ್ ಕೊಟ್ಟಿರ್ತಾರೋ ಅಥವಾ ಎನರ್ಜಿ ಲೆವೆಲ್ ಕೊಟ್ಟಿರ್ತಾರೋ, ಎಷ್ಟು ಟೋಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ಬೋದು, ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಬಬಿಲಿಟಿ, ದಟ್ ಈಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್ total electrons if they ask for, then you can substitute that value. Then you are easily going to get that answer. Then if you go for this, here in any orbital we can find only 2 electrons. In one orbital we can find maximum of only 2 electrons. ಒಂದು ಆರ್ಬಿಟಲ್ ಎರಡಕ್ಕಿಂತ ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. We'll come to know how it is. Then, position and momentum of electron can be determined at the same time. Here, ಯಾವ್ದಾದ್ರು ಒಂದು ಆರ್ಬಿಟ್ ತಗೊಂಡಾಗ ಆರ್ಬಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ ಆರ್ಬಿಟಲ್ ಇದೆ ಅಂತ ಹೇಳ್ಬೋದು, ಪೊಸಿಷನ್ ಹೇಳ್ಬೋದು, ಮೊಮೆಂಟಮ್ ಹೇಳ್ಬೋದು. ಬಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಆರ್ಬಿಟಲ್, it is not possible to determine the exact position and momentum of electron at the same time. These are the differences between orbit and orbital. We can solve certain objectives now. First question. The uncertainty principle was enunciated by, so that is given by whom? Einstein, Heisenberg, Rutherford, Pauli. I know you can give the right answer. Which is that right answer? Option B is the right answer, that is Heisenberg. Because you can remember Heisenberg, once you remember this term uncertainty, that is Heisenberg uncertainty principle. Then second question, according to Heisenberg's uncertainty principle, which is that correct expression? You have to go for first option, E is equal to mc square. It's wrong. Delta x into delta p is greater than or equal to h by 4 pi. This one and the same, that is the exact answer. Then C is lambda is equal to h by p. It's absolutely wrong. And last expression, delta x into delta p is greater than or equal to h by 6 pi. It is not 6 pi, 4 pi is the right, that is the correct answer. Therefore, which is the right option? Option B is the right option. Then next question, the wave mechanical model of atom is based upon. So finally, whatever the different concepts we have learnt in this chapter, finally we went to the quantum mechanics. Then you can consider that wave mechanical model. Here that wave mechanical model of atom is based upon which theories? De Broglie's concept of dual characteristic of matter. De Broglie's wavelength expression, if we consider that electron has got both particle property as well as wave property. Then Heisenberg's uncertainty principle, it is highly impossible to determine the exact position and momentum of a moving electron. Then Schrodinger wave equation, Hamiltonian, psi is equal to E psi. Then all the above, that means all these concepts will be merged in case of wave mechanical model. This wave mechanical model will accept all these theories. Therefore, we can say that wave mechanical model of atom is based upon what? All these. That means option D is the right answer. Then, if uncertainty is in that position of an electron is 0, the uncertainty in its momentum would be, first you should remember Heisenberg's uncertainty principle expression. What is that expression? Delta x into delta p is greater than or equal to h by 4 pi. Here they have mentioned 4 options here. If uncertainty in position of an electron is 0, that means position means delta x value is 0, then he is asking for the uncertainty in the momentum. Then if you want to calculate delta P is equal to h by 4 pi into, this will come to the denominator, then we can say delta x. Therefore, delta x value, what they have mentioned, 0. So 0 with any number, you will get that product will be 0. Any number by 0 is exactly equal to infinity. Therefore, which is that right option? Option D is the right option. So 0, h by 2 pi, h by 2 pi. So here we can mention it should not be h by, it is lesser than h by 2 pi, it is greater than h by 2 pi, and last infinity. This is the right answer. Then for an electron, if the uncertainty in velocity is delta v, uncertainty in velocity value ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, delta v ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. The uncertainty in its position, that is delta x, is given by, you should find delta x. In case uncertainty in velocity as mentioned, not momentum. What to do for this? First, you start with the expression. Same expression ಏನಿದೆ ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. Delta x into delta p is greater than or equal to, I am using equal to h by 4 pi. ಈಗ ಅವನೇನು ಕೊಟ್ಟಿದ್ದಾನೆ, delta v, velocity delta v ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ we can expand this delta p, delta x into delta p ನ ನಾವು delta into mv ಅಂತ ಬರ್ಕೋಬಹುದು. ಯಾಕೆ? p is nothing but momentum, product of mass and velocity. You know that which is fixed, mass will not change. ಹಾಗೇನು ಮಾಡ್ಬೋದು, delta x we can consider it as delta x ಬೇಕಿದೆ ನಮಗೆ, delta x is equal to h by 4 pi ನಮಗೆ ಮಾಸ್ ವೇರಿಯೇಷನ್ ಆಗಲ್ಲ, ಚೇಂಜ್ ಆಗಲ್ಲ, ಅದು ಮಾಸ್ನ ಹೊರಗಡೆ ಬರ್ಕೋತೀವಿ, m ಇಂಟು ಡೆಲ್ಟಾ ಅಂದರೆ ಚೇಂಜ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಚೇಂಜ್ ಇನ್ ವೆಲಾಸಿಟಿ. ದೇರ್ಫೋರ್ ಡೆಲ್ಟಾ x is equal to h by 4 pi m delta v. So which is that right option you are getting? So that is option C. You are getting the right answer, h by 4 pi m delta v. So option C is the right answer.